In this podcast, we'll continue to discuss what kind of information about the function we can gain from reading the graph. And now we're going to introduce a little bit of new terminology. First off, whether a function is increasing or decreasing, and on what interval is it increasing or decreasing. And we'll introduce the concept of a relative max or a relative min. If I'm starting to graph a function, and I look at the function, say this function here, as it proceeds from left to right, you would say it's increasing because it's going up. However, if I look at it from the right to the left, you'd say it's decreasing because it's going down. So we need a convention so that one person won't say it's increasing while another's saying it's decreasing. So we're going to read increasing and decreasing from the left to the right, just like you read a book. So as I'm moving from left to right, this is going up, so it's increasing. Whereas this one would be going down, so it would be decreasing. And if it got to a point here at which it just stayed flat, we would say it is constant. And then we want to know, well, suppose this is your function. On what interval is it increasing? On what interval is it decreasing? And on what interval it's constant? And the intervals that we're going to be looking at are all x-axis intervals. So we say, well, it starts decreasing here at x equals -3. It keeps decreasing until it gets to x equals -1, so it is decreasing on -3 to -1. Notice I used open interval notation. We will always do that for increasing and decreasing. Now the function stopped decreasing right here. And then it started increasing. So we would say this interval that starts at -1 and goes all the way to x equals 2 right here is the interval on which the function continuously increased. So we would say it was increasing on -1 to 2. And once it hit 2, it got flat. It stayed flat. If it stays flat forever, we'd say it's constant on 2 to infinity. Now, with that in mind, let's go up and answer the questions for the function above. The first one says, on what intervals is the function increasing? Well, we want to move from left to right. We see the function going up here, and it starts going up. Now you got to look on the x-axis. So it starts going up when x is -5. When x is -4, it's going up, but don't say the increasing interval is -5 to -4, because it's still going up when it hits -4, and it's still going up when it hits -3, and it keeps going up till it hits -2. So it is increasing on -5 to -2. Remember, that's an x-axis interval from here to here. Through that whole period of x's, it was going up. Well, it's also increasing over here. It gets down to a low point here at 2, and then it rises continuously, and the arrowhead means that keeps going all the way to infinity this way and infinity that way. But we're looking at the x-axis, so it starts increasing here at 2. It keeps increasing to infinity. So we would say 2 to infinity. Well, are there any intervals on which it's decreasing? Well, it stays flat here, so that's a constant interval. When it gets here to x equals 0, the function starts going down, and it keeps going down to 2, so that would be 0 to 2, this interval right here. Look at the function on that interval. That function is going down the whole time. On what interval is it constant? That's pretty obvious. It's constant from here to here, so that is -2 to 0. What is the domain? The domain is the set of all x values for which the function is defined. So what's the x value of this point? Well, you'd read it off the x-axis. It would be -5. Well, what's the x value of this point? Well, you'd read it off the x-axis, -2. Here, +2. Here, +4, and the function just keeps going. It never stops. It goes forever this way. So we would say the domain, an x-axis interval, is -5 all the way to infinity on the x-axis. Just think of collapsing that function down on the x-axis. What numbers on the x-axis did it cover? It covered everything from -5 all the way out to infinity. Now the range is the only time we measure on the y-axis. If I collapse the function this way to the y-axis, the lowest y that gets covered is 2. What's the highest y that gets covered? Well, the function keeps going to infinity. So all the y's up here get covered. So we would say -2 to infinity for the range, and that's the only time we'll use a y-axis interval. Now the next thing we want to talk about is a relative max and a relative min. And a relative max is a spot where a function was going up, it reached a highest point and starts going down. If it doesn't start going down, we don't call it a relative max. If it just goes up to here and stops, we don't call that a relative max. It has to go up, reach a highest point, and then start right back down without any gaps. Same with a relative min. If it's going down, it reaches a lowest point, it has to immediately start back up so that there's only one point that's the relative min. And if it goes down and stops, that's not a relative min. It has to reach a lowest point and start back up again. So the question asks, what is the relative max of x? Well, as I go up here, it's increasing, but when I get here, it doesn't start going down. It stays flat. Up here it's increasing, but it just keeps increasing. It never reaches a highest point. So there is none. So I'll just say, not there. Well, does it have a relative min? Well, it reaches a min right here, but then it doesn't start going up again, so we can't call that a relative min. Well, it comes down and reaches a min right here, and then it starts right back up again. So now the way we state that, the relative minimum is at the point x equals 2, y equals -1. We say the relative minimum is the y at the x. So we say it has a relative minimum -1 at 2. The next group we did on the last one, we're trying to evaluate the function. Remember that the f of x is the y. And the number inside is the x. So we're saying, what is y when x is -5? Well, here's x is -5. If I look down at the point, y is -2. Well, what is y when x is -1? Well, here's x -1. Where's the function? Well, the function's up here. Well, what value of y does that correspond to? Well, that's a y equals 3. And finally, at f of 1, when x is 1, what is y? We'll come over here to x is 1. The function is right on the 0 mark, so it is 0. And the last question said, suppose y, or f of x, is -2. What is x? Well, let's see if there's any place where y is -2. Well, this point right here corresponds to -2. It's the lowest point on the graph. No other point corresponds to -2. Well, what is x right here? Well, x is -5. So we put here y is -2 when x is -5. That completes the podcast.